on how Google uses AI and ML in the enterprises. Well, we have with us our speaker, Richard Dutton, the head of machine learning, Google, United States of America. Richard was a tech lead in Bigtable at Google following a 15-year career working in data and analytics across both tech and finance in the New York and Seattle, US, Europe, and Asia. Well, now it is time to call upon Richard on your screen and stage. Over to you, Richard. Thank you.
Hi, my name's Rich Dutton, and today I'm going to tell you how, using AI, my team is saving Google hundreds of millions of dollars. First, a little about me. I was always really interested in math and computer science, so it was very natural for me to go on to study those things at university and then take my final year in AI. From there, I spent a bit of time at Microsoft working in speech recognition before moving back to the UK to work in finance, supporting trading desks around the world. I actually spent just over a year in Singapore around 2014 working in MBFC for Barclays Capital. And then around about that time, the markets, as you may remember, were in a terrible state. So I decided it was time to take a bit of time out and reboot my skill set. So I went over to Thailand for a while, did some Thai boxing, and while I was there, kind of re-upped my education on everything that happened in AI in the meantime. I was doing Coursera courses, reading blog posts, I was all over Twitter, and through all of these things, reading research papers, managed to get to a point where I could go and work in data at one startup and then another, then a hedge fund, and then finally progressed into Google. And that was just a few years ago. I started off working in Bigtable and then some time on Assistant, Google's number one AI product, if you like, before getting the chance to run all of our enterprise AI efforts, which I've been doing for the last couple of years. So, as you may know, at Google, we do a thing or two with AI. We have a research department of some 4,000 people producing papers across the gamut of AI topics, fairness, interpretability, new vision models, so on and so forth. We have another huge team building TensorFlow, Keras that you can use yourselves, and then a whole cloud AI product area building really high-level, easy to reuse kind of model principles that you can just drop into your own applications to do things like speech recognition, image recognition, TTS, and so on. So wouldn't it be odd if we weren't using AI for the very business of running Google itself? And that's what I'm going to talk to you about today. I'm going to talk first about some of the business challenges that we're facing at Google, where we're using AI to create efficiencies, exploit opportunities, reduce risk, and otherwise innovating. I'll talk a little bit about how we built and structured our enterprise AI team. And then, of course, I'm going to share some technical details, tips and tricks, considerations to keep in mind when employing AI in your own organization. So first, I'd like to talk through some of the areas to which we've applied AI. And our team really works across the business of Google. So there's really no limit to the areas that we have worked in. But I've picked a number of areas today that I think are most emblematic of the work that we're doing, and also will have significant overlap with your own organizations and present opportunities for you too. So today we're going to talk about 4 of those areas. We'll talk about support, HR, facilities, and communications. So, like yours, Google's employees need support of various kinds. To be honest, probably more, since we're quite a fussy bunch. And we have a single ticket system through which I can file a ticket for anything from my certificates expired on my laptop to can you please change the coffee in the micro kitchens back in the days in which we used to actually go to the micro kitchens. So you can imagine with a huge company such as Google, everyone filing tickets for the craziest little kind of requests to improve their working life. We're talking about an insane number of tickets, and just routing these things could cost a fortune. But this is the kind of area where my team comes along, working with one of the more vertically aligned teams who maybe supports that ticketing system. We can say, well, hey, this ticket routing problem is actually just a multi-class classification problem. We have the ticket text, which we can now encode easily using a technology like Google's BERT or XLNet, T5 perhaps. And then from there, it's simple multi-class classification. Feed it through a neural network into a softmax layer, and we're done. So that's great, and that saves us a ton of money, as well as enforcing stricter privacy with people's sensitive ticket data. But we can actually go one step further. We have just released a system which automatically resolves people's tickets. So if someone files that request for help on an expired certificate, that's the kind of thing that our technical support people will see all day long. So we know the answer to that. And with a simple, either a simple classifier in certain cases, or in other cases, a two-tower neural network, we can build a knowledge base and thereby automatically, when a new question comes in, encode that in a vector space, and then look up the answer that's closest to it in vector space, return that, and hopefully solve the user's problem. And then if we want to string together kind of a multi-turn conversation between a user and a virtual agent, we can use chatbot technologies like Dialogflow, and we can guide the user from the initial kind of imprecise specification of their problem through clarifying questions right the way to confirmed resolution. And however we resolve these things, it's still important for us to be able to look at the macro view. And so we have analytics oriented models whereby we can cluster all of the tickets, and we can see how they're broken down over time, and then we can actually see which clusters are emerging or disappearing over time. And in that way, if we see a new cluster appearing, say referencing the network in New York, and we see more and more tickets being added to this cluster, we'll get an alert and we'll know that we've got a problem, and we can start to proactively address it. So I talked a bit about supporting our people, but their professional growth and development is equally important to us. If you know anyone at Google, you've perhaps heard something about our performance management process. It is incredibly time consuming and laborious. So anything that we can do there to either make the process more efficient or more efficacious, since it's so important to us too, is highly valued. And just one area where we're able to use machine learning here is in selecting appropriate peers. Google has a peer review based performance management system. And so, at the end of a long 6 months or year, selecting the 12 people with whom you've worked most closely and who are most likely to give good feedback isn't necessarily a trivial task. But it is a task that we can easily build a classification model for. And we've done that. We've actually classified people's peers in a binary manner as this person is likely to give good feedback versus not. And in that way, we kind of narrow down a long list to a much shorter list, and then allow people to kind of verify that list before it's submitted. Of course, using recommender system technologies like we'd find in YouTube, we can suggest all kinds of resources for people. We can suggest internal courses for them, external courses, we can even suggest mentors. And taking that one step further, if someone's ready to move on, we certainly don't want to lose them from the company. So we can suggest interesting internal roles to people. Finally, space optimization it's always been a terribly important problem for us. We have crazy amounts of money tied up in real estate that we want to make the maximum use of. And of course, with coronavirus, this gets kind of yet more interesting. Optimization problems can be solved, obviously in most cases, perfectly, but we can get quite far as well with a fuzzy optimizer built using a neural network, and even an algorithm that can tell us whether an optimization problem is likely to be soluble or not can be very helpful. And so an example of where we've done some work here is with meeting rooms. At Google, you no longer have to specify meeting rooms. They'll get picked for you automatically. And we can tell you, again, using one of these classifiers, on a day in which you're in the office at least, when you're booking the room, how likely you are to actually get a room at the end of the day, or whether you should just give up on this meeting of 100 people across all sites simultaneously altogether. So also important to the well-being of our people are the facilities that we work in. And keeping the devices that hum away in the ceilings and the floors working optimally is a very challenging task, particularly since we don't necessarily have great labeled data. Like when an air conditioning unit's playing up, like in an ideal world, someone files a ticket, but in the actual world, that doesn't happen very much. So, faced with this kind of unsupervised problem, my team built an anomaly detection service and actually a new algorithm which was presented at ICML this year. That allows us to detect anomalies in univariate and multivariate space and to explain where they came from. Just check out John Sipple multivariate anomaly detection on Google if you would like to learn more about that. Even more exciting than that, and even more kind of cost saving, we can automate the very buildings themselves using machine learning, as DeepMind demonstrated with data centers not so long ago. That's a project that we're working on this year, whereby we'll have a reinforcement learning agent kind of setting the controls on an individual air conditioner to be just right to make the rooms kind of optimally comfortable for people while not wasting energy cooling them or heating them unnecessarily. Another area where we can save tons of money is in predicting the demand for a given cafeteria on a given day. We have a ton of cafeterias at Google, and we never know who's coming into work that day anymore and which cafeteria they're going to go to. And so using features like the menu, the weather, historical record, we can predict how much food the chefs should cook at a given cafeteria on a given day and save tens of millions of dollars, let alone like incredible amounts of food waste. And then there's problems of inventory management. If you imagine like being a big company like ours and probably yours, we have tons and tons of hardware sitting around just waiting to find out when people, or just waiting for people to want to use it. And this could be a problem when that hardware suddenly becomes out of date and you're sitting on a ton of it. You'll kind of wish that you got rid of it several months ago. So we have a simple classifier there, built actually using AutoTFX, a variant of AutoML that I'll talk about in a little while. So for very little effort, we were able to address this problem and save ourselves, again, tens of millions of dollars. Final area, all the more important during these coronavirus times, is communications. We're doing so much video conferencing now. And we worked in my team on a system to detect when video conferencing units were broken, using again that kind of anomaly detection platform that I mentioned earlier. Unfortunately, this was a case of something that just didn't work. And so, I think it's very important to kind of be able to maturely assess how a machine learning project is going, whether you're actually seeing the signal, where you've got to where you thought you would be at this stage, and just get out of it if it's not working out. And we did that, and it turns out that some of the technology we built along the way, in this case to do anomaly detection on textual data, as you'd find in log files, we're now able to reuse in a new project. But certainly glad that we stopped that one. We obviously do tons of document classification. Again, something that's really trivial to do with AutoML. And increasingly doing summarization, so like summarizing the entire chat channel. So if I go away for a day and come back, I can get a simple kind of like 5 or 10 bullet point summary of everything that's happened on that channel. Also, document similarity, again, encoding documents in a vector space, it allows us to look at documents that are close to them in that vector space, and in that way find similar documents or deduplicate documents. So, having kind of duly motivated ourselves, like how did we go about building this team? Well, we set a mission for ourselves to use applied AI as competitive advantage in the enterprise for Google. And the way that we go about that is through three pillars. Implementation, as you'd expect, building models. We tend to do that when there's something complex, interesting, reusable to do. Empowerment, helping others build their own models, others across the kind of enterprise IT space. We can send them away oftentimes with AutoML or teach them enough ML to get going. And we do a lot of education of leadership as well to make sure that they're aware of the opportunities in each of their vertical spaces. And of course, research, something I'll talk about in a little while. We stay on top of all of the cutting edge research as applies to enterprise AI. And here's our team. We are perhaps smaller than you might expect, but we get a ton done. We have at least 4 things going on with every one of the engineers that we have. We have a product manager helping to flesh out what those systems are going to look like, and a program manager just to stay on top of all of these different engagements, education, public speaking, all that kind of thing. In addition to, of course, having a couple of leads of the team, such as myself. And now finally, I'll talk about some of our considerations of a technical nature. And this will really be some of that research that I mentioned. We spend a lot of time staying on top of this stuff because when you're in a corporate setting or enterprise setting, a lot of the data that you're dealing with, it either is kind of about people or it has an impact on people. And that means that we see the same things coming up again and again and again. Our privacy is, of course, all over the news at the moment and incredibly important. And the good news is with cutting edge research, you can do a really nice job of doing machine learning without even looking at people's data, without even necessarily pulling it onto your own machine. So I encourage you to look into all of the technologies I'm showing here and as linked kind of at the bottom right of the screen there. A very similar link at the bottom there, you'll see a lot of the work that Google's doing in fairness. Again, when you're dealing with people data, you have to be very, very careful that the decisions that your model's making are fair. The canonical example is if you have a fraud detection model, you don't want it to be biased against certain ethnicities or genders or so forth. And unfortunately, if you're not incredibly kind of principled, careful, and if you don't apply oftentimes a lot of this really cutting edge stuff, then you are inadvertently going to build a model which is perhaps even more biased than the data that you trained it on. So again, this is something we take very seriously. And we stay on top of all of this stuff and much, much more. Finally, interpretability. Imagine I've got a classifier that determines if something's a clog or not. It correctly deems this a clog. But imagine that it incorrectly deems this small child a clog. How do we know what's going on? Well, again, using some technologies coming out of Google Research and others, integrated gradients here, we can see exactly what the model's looking at when it's looking at that small child. And perhaps you would agree that what we see in the center there actually does look a little bit cloggy. Again, for more information, check out that link on the bottom right. So, finally, a piece of good news to send you away with. I've mentioned it a couple of times already, but AutoML is something that we're able to use more and more now. When we have a simple problem, perhaps a classification or a regression based on simple structured or text data, we throw it into AutoML and get a kind of peak performance model at the back end, sometimes in as little as kind of 2 months from the very beginning of thinking about a project to actually delivering value into production. So I encourage you to check that out. So with that, I'll leave you. Please do think about opportunities that might exist within your own businesses, similar to those that I've outlined. If you don't have one, consider a cross-functional kind of team of enterprise AI specialists. And as I say, have them be aware of all those complexities and that cutting edge research, as well as keeping AutoML in their back pocket to pull out and surprise people with how quickly you can turn value around. Thank you.
So ladies and gentlemen, well, that was our speaker. Thank you so much, sir.